This is the homework for 467, A, B, and C, 68A, and 71C. In problem 467, you need to use what you know about M and B to graph each equation without using a table and show your growth triangles and the x and y intercepts. For problem 67a, I have y equals mx plus b, m being the growth rate. If you see the growth rate, this doesn't line up. This doesn't look like the growth rate. Here's the growth rate, negative 2x. It's the value in front of the x. So what I did is to show it in a more familiar form, I put it in y equals mx plus b form. So here is the rate of change, the growth rate, and then the b, the initial value, or the y-intercept, is going to be positive 3. And there's a 3 there, and that's a positive 3. That's why I wrote plus 3. So on the y-axis, that's where we'll find the y-intercept, or the initial value. So when y equals negative 2x plus 3, our initial value, y-intercept is right here. And from there, we have a negative 2 growth rate. And remember, I talked about the tree. The tree is falling towards the negative x's, negative 2. So you know the slant of this line is going to be slanting towards the negative x's. So we have a negative growth rate of negative 2. So from our y-intercept, I can go negative 2, positive 1, or from here I can go positive 2, negative 1, because both would make negative 2. Negative 2 divided by positive 1 is negative 2. Positive 2 divided by negative 1 is negative 2. So I can continue that same growth rate, positive 2 over negative 1. Positive 2 on the y, negative 1 on the x. Positive 2 on the y, negative 1 on the x. Positive 2 on the y, negative 1 on the x. Or I can do negative 2 plus 1. Negative 2 on the y, positive 1 on the x. Negative 2 on the y, positive 1 on the x. Negative 2 on the y, positive 1 on the x. So here is my negative rate of change. For 67b, I have y equals mx plus b, and on this one, I don't have a b value, my y-intercept. I have my rate of change, my growth rate, which is a positive 2. So if I don't have my b value, I can add 0. Because y equals 2x plus 0, that plus 0 doesn't change the value of 2x. But it does let me know where my y-intercept is, which is at 0 on the y-axis. So here's my starting point, and then I have a positive 2x. Well, positive 2 could be written as 2 over 1, because 2 over 1 equals 2. Or I can write it as negative 2 over negative 1, because negative 2 divided by negative 1 equals a positive 2. So starting up my y-intercept, positive 2 on the y, positive 1 on the x. Positive 2 on the y, positive 1 on the x. Or I could do negative 2 on the y, negative 1 on the x. Negative 2 on the y over negative 1 on the x. In problem 467, it's a little different because we have y equals mx plus b. We had y equals 3. Well, we just have the y-intercept and no growth rate. So if there's 0 growth rate, I wrote it like this: y equals 0 multiplied by x plus 3. And if you look, if I said if x is 0, on the y-intercept, y is going to be 3. That's our, I mean, on the y-axis, y equals 3. That's our y-intercept. Well, if x equaled 1, 1 multiplied by, if x equals 1, 0 multiplied by 1 is 0 plus 3. So 1. So it would be also 3. Y would be 3. If x is 2, 0 multiplied by 2 is 0 plus 3 is 3. So if x is 2, y is 3. So it doesn't matter what value I put in for x, I'm multiplying it by 0, I will always get 3. If I put y equals 1 million, I would go positive 1 million on the x-axis, but the y would be 3. So there's no growth on this. So in problem 468, I needed to complete the table and write an equation that represents the table. So these were the values that were given, 0, 5, 1, 7, and so forth. And down here in the pink were the values that were not given. Well, to find the rule or the equation, I have my starting point, my y-intercept, when x is 0, y equals 5. That's the b value, which is 5. To find my growth, for every 2 on the y, I'm increasing 2 on the y for every 1 on the x. Increasing by 2 for every 1 on the x. Well, that's where we have 2 over 1. Our rate of change. 2 divided by 1 is just 2. So our rule or equation would be y equals 2x plus 5. Now I can use this rule to find the missing values in the table. If I know that x is 30, I plug it in for x. 2 multiplied by 30 is 60, plus 5 is 65. If x is 200, 2 multiplied by 200 is 400, plus 5 is 405. In order to find out when we know the we know the y value, and we need to find the x value, that was the missing value, we plug in 505 in for y. So instead of y, I have 505 that was given in the table for the y value equals 2x plus 5. And then I go ahead and solve this by using inverse operations. Inverse property of addition is subtraction, so we subtract 5 from both sides. And I get 505 minus 5 is 500 equals 5 minus 5, that's a 0 pair, so I'm left with 2x. Now I have 2x, this is multiplication, inverse property of multiplication is division. I divide both sides by 2. This is identity property, it's the giant 1 in identity property multiplication. And I'm left with x, and 500 divided by 2 is 250. So x equals 250. And that's the value we got there. In problem 471C, you needed to find the area and perimeter or circumference of the figure. You're also saying by now that I probably gave you too much homework, and I probably did, so I apologize for that, but you still need to do this problem. So the area is the easy part of this. So we need to define the area of the shaded region only. Well, you know that it's the red area is 1 out of 3, so it's 1/3. So first we're going to find the area of the full circle, and then we're going to divide it by 3 because we only want 1/3 of it. So in previous problems, I had mentioned about area of a circle is area equals pi r squared, or apple pies r squared. Just an easy way for me to remember the formula for it. So area equals pi multiplied by the radius, and the radius is 12. That was given from the center point to the edge of the circle, which is 12 feet. So we have 12 squared, which is 144. Now you can see I have these little squiggly lines, and this means instead of equals, it's approximately. So because I approximated pi as 3.14. So area is approximately 3.14 multiplied by 144, which is approximately 452 and 1600ths. Well, that's the area for the full circle. We only want 1/3 of it. So we're going to divide it by 3. And so once I divide it by 3, I get approximately 150 and 7/10 cubic feet. I'm sorry, not cubic feet, square feet. Cubic would be to the 3rd power. The second part, we need to find the perimeter of the shaded region. And the perimeter is the length of all the sides. So we have this arc, this radius, and this radius. Remember, circumference is like the perimeter of the circle. It's the distance around. So, but we only need, again, 1/3 of that. So first we're going to find the circumference of the circle, and then divide it by 3 because we only want 1/3 of it. And then, so once we have this arc, then we can do the other part of this, 12 and 12, because if this radius is 12, this radius is also 12. So I'm going to start out with the circumference equals pi times the diameter. And the way I remember, cherry pie is delicious. And we already know that the radius is 12, so the diameter is going to be 2 times the radius, so it's 24. Because if we were to go all the way across, 12 plus 12 is 24. And now I'm going to take pi and approximate it, which is 3.14, and now that's why I have approximation symbol. And 3.14 multiplied by the diameter, 24, is approximately 75 and 3600ths. So I found the circumference of the circle, but I only need this arc, 1/3 of it. So I divide it by 3. So 1/3 of the circumference is approximately 25 and 1200ths. It's right here. And I know these doesn't look equal, but it's supposed to be equal. Just pretend like they're 3 equal portions. I messed up. So we know that this arc is 25 and 1200ths feet. And then we want the perimeter of it, so then we add 12 plus 12 more, which I have done here. And so we get the perimeter is approximately 49 and 1200ths feet.